Okay, so today we want to shift sine and cosine functions. So there's going to be more things going on. Okay, last time we talked about that A was the amplitude, or technically the absolute value of A was the amplitude. And then we said the period for these two functions was 2 pi divided by the absolute value of B. Right, you always want the period to be a positive value. We want to talk today about a vertical shift and what's called a phase shift. Okay, the vertical shift is really pretty self-explanatory. I think it seems to go pretty easily because you actually evaluate the function, then you deal with it. The phase shift will actually influence how we create our little XY table, so that's kind of a thing. Right? So what you're going to find is, if these are written, it's A times sine and it's B times the quantity x minus h. Sometimes you'll even see this written in a big bracket here to show you that's all inside of the sine function or inside of the cosine function, correct? But we have this number multiplied by the outside, and that's going to show us what our period is. And then we have this phase shift number, which is whatever x minus h is. If you remember, anytime we're translating, it seems like if it's with the x, it's sort of the opposite of what you're seeing. So in this case, if it's x minus 2, it means the phase shift is plus 2. If it's x plus pi over 2, it means the phase shift is minus pi over 2. That'll help us build our table. So that's going to be h. And then the vertical shift is just we're going to move it up k units. And again, with the method that we're using, the two pieces that we really have to be aware of before we make our table would be the period and the phase shift. The other pieces will take care of themselves when we plug the numbers into the function. They should just be taken care of. Now, sometimes we'll look at some more things here. But let's look at number 2 from the paper you have in front of you, which is g of x equals 4 minus 2 sine x. Okay, so with this one, it doesn't have everything we've talked about over here, but we can still kind of list our facts. It will be a good way to start. So with this, we have 4 minus 2 sine x. We're not allowed to subtract 4 minus 2 because the 2 is being multiplied by something. Order of operations says you have to deal with your multiplication before you deal with your subtraction. But this 2 right here is going to be our amplitude number, correct? Or it might even be helpful to think of this as g of x equals negative 2 sine x plus 4. That would put it more like in this form, correct? Where we can see the plus 4 is actually the vertical shift, actually the k number. So with this, our amplitude will be 2, right, because there's a negative 2 in front. The amplitude's always the absolute value of that number. Our period will be 2 pi divided by, well, there's no number multiplied by x, is there? So it's just 2 pi divided by 1, which is great. It's just 2 pi. Right? That's the easiest one for us to do. Our phase shift, right, that occurs if there's some number being added in here by the x, but there's not, right? So there's none. And then our vertical shift would be this plus 4. So it's going to move 4 units up. But again, the vertical shift is we're going to be able to take care of that just when we make our table here. Okay, so to make our table for this function, if we have a phase shift, this is always going to be now the starting point of our table. Okay. So we're yesterday and earlier today, we always started at 0 for our first entry. If there's a phase shift, we're going to start with that number. Right? If the phase shift is a positive, you start with that positive number. If it's a negative, you start with that negative number. We'll see our second example, how that works out. So then with this, we're still starting at 0. We're going to 2 pi, pi over 2, 3 pi over 2, just our typical, right, values, the usual suspects here. Now we just have to plug into this function and see what we get. So I'll probably still use the first version. So 4 minus 2 sine of 0. Well, what's the sine of 0? 0, right? So 4 minus 0 is just 4. We there. And then we have 4 minus 2 sine of pi over 2. We know the sine of pi over 2 is 1, so that's 4 minus 2, which will be 2. And then we get 4 minus 2 times the sine of pi. Sine of pi is 0, so 4 minus 0 is 4. Is this working so far? Again, just kind of plugging them in, evaluating them. 4 minus 2 times the sine of 3 pi over 2. Well, that's negative 1. So for this one, you get negative 1 times negative 2 is plus 2. So we get 6. And then 4 minus 2 times the sine of 2 pi will give us 4. So here we have one full period, correct? And that's going to help us answer some other questions that we have on this one about the domain and the range. But to graph this, again, make sure we label it. So let's do 2, 4, 6. So we went ahead and labeled our values. Let's see what we have. 0, 4 is up here. Pi over 2, 2 is down here. Pi 4. 3 pi over 2, 6. 2 pi 4. So here's one period of a sine curve. Now we could put more, but actually it's kind of nice to just sometimes look at one. Can we see, where's the midline at here? 4, right? That's what the vertical shift does, is it moves the midline. Now if we look, you see the amplitude is still 2, right? It goes 2 above the midline and 2 below the midline. Same thing's going on. So when we do this, now again, if we wanted to put other points, we could do that. We could continue it on. Things like that. But I think it asks us about the domain and the range. The domain is still, x is a real number. That'll always be the case for a sine and cosine, unless our problem has some restriction attached to it. And then our range in this case will be from 2 to 6, which actually, you could figure that out without graphing it, right? If we know the midline is at 4, right? And then we know that the amplitude is 2, so you're going to go from 4, you're going to go down 2 to 2, and then you're going to go up 2 to get to 6. So you can usually tell pretty quickly the band of where your values are going to lie, just based upon the vertical shift, right? The movement of the midline and the amplitude. Okay, so for our second example, this is number 4 from the back of the worksheet. We have a lot more going on, right? We have 3 cosine, 3 times x minus pi over 6. Now you might see this all in a bracket to realize it's all in the cosine, but it's pretty standard to see it written without it because, I don't know, that's why you don't really put stuff behind the cosine that's not in the cosine. You keep it out to the left of it to help with that. I do think, though, on the delta math, there is one part where they're not quite written like this, but you'd have to actually whatever's in front of the x, you'd have to actually factor it out, that parenthesis, to get it to look like this. Meaning, like if you have like 4x minus pi over 8, you have to factor out the 4, and then you could get it right. So that's a little bit down the road. But so to look at this one, we're asked about the period and the amplitude, which are easy to find, but the big thing we need to find here is the phase shift. That's going to give us a lot of information that we need. So for this one, the amplitude, again, that's the multiplier out front, and that's going to be 3. Now, is there a vertical shift here? Is there a plus or minus number outside of the function? There's not. So actually from that, we already know, because it's a cosine function, the domain is all reals. And it means the midline will be at 0. It'll go 3 above it and 3 below it, correct? So we actually already know that our range is that y is from -3 to 3. Right, so it's really easy to see where your answers are bounded by. That doesn't really help you make the graph a lot, but it's good information. Right? If it asks you what's the maximum, you say 3. What's the minimum? You say -3. You don't have to do any work. That's a good thing to know. The period, that's still going to be 2 pi divided by b, so that's going to be 2 pi over 3. And then the phase shift, which we really have to nail that down. That's going to be the number in here with the x, right? So it'll be x minus a number or x plus a number. But if there's any numbers actually multiplied on the x right there, we can't tell what the phase shift is. So it has to be in this factored form to make this work, which might come up later on. But we have x minus pi over 6, which means the phase shift will be positive pi over 6. Okay, it's that opposite piece. So now to make our table, instead of starting at 0, which we've always done before, when you have a phase shift, you start at the phase shift. So we're going to start here because that is the phase shift. And then we're going to end at the phase shift plus 1 period. Okay, before we'd always do 0 plus 1 period, which looks a lot just like 1 period. But here we're going to do the phase shift plus 1 period. So to do that, we need to take the phase shift, which is, we have to do some arithmetic here, pi over 6, and then 1 period is 2 pi over 3. Yeah. So yeah, and then that'll give us, let's see, pi over 6 plus 4 pi over 6. That will give us 5 pi over 6. Now again, this tends to be where people have to really be careful, is working with these fractions. But if it bugs you that there's a pi on top, you can pretty much ignore the pi. It always is just going to sit there. You know, if you have 1/6 plus 2/3, it's the same problem. So now to find this middle value, we're going to do the average again. So we're going to do 1/2 pi over 6 plus 5 pi over 6. Well, that's just 6 pi over 6, isn't it? Which is pi. So pi times 1/2 is pi over 2. The next one will be 1/2 pi over 6 plus pi over 2. Let's see, that's 1/2 pi over 6 plus 3 pi over 6. Right, so that gives us 1/2 times 4 pi over 6. And here I would reduce the 2 and the 4. I think is the best way to do this here. Reduce the 2 and the 4. Oh, actually, and could reduce lots of stuff. So we get 4 over, yeah, so we get pi over 3 when you reduce all that. Right, because you can take the 2 and then make that a 2 and end up with the bottom. So that gives us pi over 3. Now here at this point, we could do another average, which is fine. Pi over 2 plus 5 pi over 6. Well, that's 3 pi over 6, isn't it? So 3 pi over 6 plus 5 pi over 6 is 8 pi over 6, which is 4 pi over 6, which is 2 pi over 3. Okay. So, fractions, right? They're a thing. They're not going anywhere. Now, you might notice, too, if you think of everything as being over 6, that's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. If you can see that pattern, whether sometimes I'll do that one this way. You get 1 pi over 6, 2 pi over 6, 3 pi over 6, and 5 pi over 6. Oh, I wonder what's missing. 4 pi over 6. So I do it that way, but if nothing else, it's a great way to check. They should all be evenly spaced. That should be a thing. Okay, so now that we have these, we just have to plug them in and evaluate. I'm going to get rid of this work here. It's on the video if you need it. But so from here, I'm going to go ahead to evaluate this. We'll get 3 cosine 3 pi over 6 minus pi over 6. Well, pi over 6 minus pi over 6 is 0, correct? And what's 3 times 0? And what's the cosine of 0? 1. And 3 times 1 is 3, right? So it's still, we're going to plug it in, but we should get one of those nice angles that we're used to seeing, one of those quadrantial values. So here we have 3 cosine 3 pi over 3 minus pi over 6. A little bit tougher here. So this is 2 pi over 6, isn't it? Minus pi over 6 is 1 pi over 6. Pi over 6 times 3 is pi over 2, right? That's what we wanted. So we get 3 cosine pi over 2, which is 0. We should still be seeing these same nice numbers that we got used to seeing, even though the x values are kind of a hot mess, right? They're a little bit all over the place in there, you know. And these are actually ones you could actually, sometimes you'll get weird stuff like 5 pi over 12 or just all kinds of weirdness. So here, 3 cosine 3 pi over 2 minus pi over 6. So let's see, that's 3 pi over 6. Take away pi over 6 is 2 pi over 6. Times 3 is 6 pi over 6, which is just pi, right? So 3 times the cosine of pi, which is negative 1, right? So that gives us negative 3. We getting the idea here? Okay, we'll work through the rest, but you know, sometimes as you get better, you can kind of see the patterns developing. So here, 2 pi over, what's this, 4 pi over 6? Take away pi over 6 is 3 pi over 6, right? 3 pi over 6 times 3 is 9 pi over 6, which reduces to be 3 pi over 2. So this is, now if you can't do that in your head, that's fine. It just means you got to write it out. That's what we have to do. And then here, 3 cosine 3, 5 pi over 6 minus pi over 6. So let's see, that gives you 4 pi over 6, doesn't it? When you subtract them, then you multiply it by 3, that gives you 12 pi over 6, which is 2 pi. So that'll give you 3. So we see that we get the same types of y values, right? The hard part is building that x column. Now, be very careful as we're labeling this. This is still an xy coordinate plane. This is still the origin, which is 0, 0. Points out here are positive x values. To the left are negative x values. Right? So if your phase shift pushes you left, you're probably going to start with points over here and then build to the right. But here we get pi over 6. Now, we said these are all evenly spaced by pi over 6, correct? Which is nice. So that means the distance between 0 and pi over 6 should be the distance between all these other points as well. That's not always the case, right? Sometimes this gap can be bigger or smaller. You just have to kind of be aware of it. It's not a huge deal, but this is pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, 3, negative 3. So up here, there, there. So here's the points that we have for that first period. Right? It's one period. Again, we could always put more. Once you see the pattern, it's pretty easy to do usually. Again, try to make it sort of sinusoidal, not saw blade-ish, but like this. So, are we good? Does this seem to make sense here? Just something that I wanted to mention this because I think it comes up on some of the delta math problems. Sometimes you're given a graph and you're asked to figure out what's the period, right? So, it's a reasonable question. So say we have this one. Now, we know what the period is because we already found it, but say that we didn't, right? So what you can do is you just have to pick one period from the graph. So you could do something like, this is actually pi out here. So you could pick, well here, maybe if you wanted to, you could pick, I would pick lots of things. You could pick 0 and 2 pi over 3. That would be a pretty easy one. Period is 2 pi over 3. But say you picked these 2 points, right? It's really easy to pick 2 peaks, right? So the distance between these two, or the period, and again, we know the answer because we just built the problem, but this is just a technique that we want to look at, is you could take the rightmost, 5 pi over 6, and you could subtract pi over 6, and that gives you 4 pi over 6, which gives you 2 pi over 3. So we get the period is 2 pi over 3. Now, if we're going to write the equation, though, sometimes it's another thing you might want to do is we know that the period, we said for every cosine, is 2 pi over b, correct? Or the absolute value of b, but say it's 2 pi over b. Yeah? So what you could do then, if that's 2 pi over 3, what do you think b is going to have to be? 2 pi over b equals 2 pi over 3. It would be 3, yeah. And if not, you could cross multiply if you didn't see that. So 2 pi times b equals 6 pi. B is 6 pi over 2 pi. B would be equal to 3. If you ever do need to do that, just from the graph, go from peak to peak or valley for valley. Be careful picking midlines, because if you pick these two, it's not a full period, correct? It has to have a high part and a low part to be a full period. So just something to keep in mind. If you ever need to find the period from a graph, which we will, that's how you do it. You find it, and you set it equal to 2 pi over b. All right, very good.